Very good morning, students. So this is the continuation video of your previous chapter, that is current electricity. So in my previous tutorial I have given you some homework like in the exercise questions and all. So in that exercise questions you see, so there are few numericals. So from there we will practice few today. Okay, so that for you it will be easy to solve the rest of the questions. So you see, I have taken one question from that exercise of current electricity, that carefully study the circuit diagram shown in the figure and calculate the value of resistor X. Okay, so we need to calculate this value of this resistor, this unknown resistor X value we have to calculate. So first we will see that what data is given in the question. EMF is given 6 volt, there is no internal resistance, and the ammeter reading is showing 0.4 ampere. We have 2 ohm resistance which is in series with the combination of 12 ohm, 6 ohm and 3 ohm. So these three are in parallel, but it's in series with 2 ohm and X. Okay, so we need to find the value of X. So first of all, what we will do, we will calculate this resistance first here. Solution. Here 12 ohm, 6 ohm and 3 ohm are in parallel. Okay, so are in parallel, so therefore 1 by R dash will be 1 by 12 plus 1 by 6 plus 1 by 3. So if you take LCM here, you will get 7 by 12, right? That is 1 by R dash equals to 7 by 12, or R dash equals to 12 by 7. So we got this 12 by 7, but this is in series with 2 ohm and X. That is total R equivalent equals to 2 ohm plus 12 by 7 ohm plus X. Okay, so if you take LCM again, 7 to the 14, 14 plus 12, that is 26 by 7 ohm plus X. Okay, so we will not write here ohm, just we will write 26 plus 26 by 7 plus X. Now we will see the total current, that is I, equals to total EMF by total resistance, right? So this is the formula we have to use here. So total current is how much? 0.4 ampere. Total EMF is given here 6, and total resistance, that is 26 by 7 plus X plus internal resistance, but internal resistance is what? 0. So this small r in the question it is 0. So we'll just cross multiply. 26 by 7 plus X equals to 6 by 0.4, or this can be written as 60 by 4, 415, or 26 by 7 plus X equals to 15, or X equals to 15 minus 26 by 7. Okay, so this one I'll solve here. So X equals to 7 5 is 35, that is 105 minus 26 by 7. So when we will subtract this one, we will get 79 by 7. Now when we will divide this one, 11 is 7, 11 is 77.27, 2 is 14, 6, 7, 8 is 56, or this can be written as 11.3 ohm. Okay, if we round off. So this is our answer. So value of X is 11.3 ohm. So this is how we solve this type of questions. First, in any network, first we will see that what is the equivalent resistance. Then we will try to calculate the total resistance. Then if current is there, we will apply the current formula. That is current equals to total EMF by total resistance. So after substitution, we will get the value of unknown resistance. So next question we have here, a battery of EMF 3 volt is connected in series with an ammeter. 10 ohm wire and with a parallel combination of resistance of 3 ohm and 6 ohm. Draw a circuit diagram. Also we have to calculate the resistance of parallel combination, reading on the ammeter, potential difference across the 3 ohm resistor, current flowing through 3 ohm resistor. So you see this type of questions generally it comes. Okay, so in this type of questions you need to draw the circuit diagram by yourself. So first what you will see that a battery of EMF 3 volt is connected in series with an ammeter. So therefore there is a battery. So we will draw the battery. It is in series with ammeter. Okay, that is 10 ohm. Now this end is connected with a 10 ohm wire with a parallel combination of the resistance. So therefore this is further connected with parallel resistor and this one is connected together, right? So this is given 3 volt, ammeter reading we don't know, we have to calculate this one, and this is given 10 ohm and this is given here 3 ohm and this is given 6 ohm, right? So what we need to calculate here, we need to calculate the total resistance of the parallel combination, also the reading of the ammeter, that is current they are asking, potential difference across 3 ohm resistor. So what is the potential difference here and how much current is passing through this resistor, right? So this is the question. So first of all what we will do, we will calculate the resistance of this parallel combination. So solution here, 3 ohm and 6 ohm are in parallel, so 1 by R dash, or you can consider this one as R1. 1 by R1 equals to 1 by 3 plus 1 by 6, that is LCM will get here 6, that is 2 plus 1, that is 3 by 6 or half, or we can say R1 equals to 2 ohm, right? So first answer, resistance of the parallel combination, answer is 2 ohm, we got answer, right? Next we will find the reading on an ammeter. Reading on an ammeter means here, that is, this was point number A. Point number B, reading on an ammeter means I equals to E by R plus small r. So what is the total EMF? That is 3. Capital R will get here 10 plus 2, that is 12 ohm. That is the total resistance here. 10 plus here we got 2, that is 10 plus 2 is 12 ohm. So 12, small r is not given in the question because internal resistance is 0. So 3 by 12, that is 1 by 4, or that is 0.25 ampere, right? So total current also we got here. So reading on an ammeter, so what is the reading here? 0.25 ampere. Third thing we have to calculate here, potential difference across 3 ohm resistor. So I'll just rub the board here. Now potential difference across 3 ohm resistor, so potential difference equals to I into R1. R1 when I say, that means R1 is the combination of this. So what is the total potential of here? That is I we got 0.25 and R1 we got here, that is 2, that is 0.5 volt, right? Total potential at 3 ohm is total potential as this. So how much is the potential here? 0.5 ohm. Okay. Next we will calculate current flowing through 3 ohm resistor. Now current flowing through 3 ohm resistor means here we know V1 equals to I1 into R. So here V1, just now we have seen, that is 0.5, I1 current we have to find, and how much is the 3 ohm? So I1 equals to 0.5 by 3, that is 5 by 30 or 1 by 6, or this can be written as 0.166 ampere. Okay, so let me make it clear once more. So first of all, resistance of parallel combination means we will find this resistance by using the formula. Next, reading on an ammeter means here total voltage by total resistance. So we will get here total voltage by total resistance 0.25 ampere. Next, we have potential difference across 3 ohm resistor. Now we have to see that 3 ohm resistor is in parallel combination with 6 ohm. So total resistance is here 2 ohm, right? So we have to use the formula V equals to IR. Now IR means not only 3 ohm, because 3 ohm is in parallel with 6 ohm, so we have to take the total combined resistance answer. That is IR1 is total. Okay. So R1, what is the total resistance here? That is 2I. We got the total current, that is 0.25. So we will get the potential difference across this branch. Next, we need to calculate here how much current is passing through this 3 ohm resistor. That means, so total voltage V1 equals to I1 R1. So V equals to 0.5. I1 we have to calculate, and which resistor? 3 ohm. So if you divide, then you will get the current through that particular resistor. So next question we have here, 4 resistors of resistance is 0.5 ohm, 1.5 ohm, 4 ohm and 6 ohm are connected in series to a battery of EMF 6 volt. So here 1, 2, 3, 4, right? 4 resistors are connected with one battery here. So according to this question, 0.5 ohm, 1.5 ohm, 4 ohm and 6 ohm. So battery of 6 volt here. We need to calculate the total current through the cell. So total current we know, total current flowing through the circuit, that is I equals to total EMF by total resistance. Total EMF is 6 volt here, and total resistance we need to calculate, and internal resistance is 0. So we will be calculating the total resistance first. That means all are in series. Therefore 0.5 plus 1.5 plus 4 plus 6, that is 2 plus 4, 6, 6 plus 6, 12, that is 12 ohm. Right? So total current will be here 6 by 12, that is 1 by 2 or 0.5 ampere. So 0.5 ampere is current is passing through this circuit. Now one thing you note, in the next point we have to find potential difference across each resistor. That means PD stands for your potential difference, or even the potential drop. Okay, so what is the potential drop across each resistance here? So we need to calculate PD here. So let us consider potential drop across 0.5 is V1, rate is V2, V3 and V4, right? So V1 equals to I R1. So V1 will be I is 0.5 and R1 is 0.5, that is 5 5 is 25 by 100, that is 0.25 volt. So likewise we will calculate for other also. Suppose for V2 is equals to I R2. So how much is the current? That is 0.5, that means 5 by 10, and R2 we have 1.5, that means 75, that is 0.75 volt. Okay, so V3 will have IR3. So I is 5 by 10 and R3 we know that is 4, that is 20 by 10, that is 2 volt. And last V4 we have 5 by 10 into 6, that is 30 by 10 or 3 volt. So these are the potential drop. So whatever V1 we got, that is the potential drop across 0.5. V2 is 0.75 volt is across 1.5. 2 volt is across 4 ohm, and 3 volt is across 6 ohm. So this is how we calculate the potential drop across each resistor. So to calculate like this potential drop, we need to calculate the total current. Then we will see that all are in series, so we just multiply with current. The resistors resistance will multiply with current, we will get the potential drop across particular resistor. So similarly, there are few questions which you can solve by looking today's questions which I have solved on the board. Like you see, question number 16, given below a circuit diagram in which 3 resistors 1 ohm, 2 ohm and 3 ohm are connected to a cell of EMF 2 volt and internal resistance 0.5 ohm. So 1 ohm, 2 ohm and 3 ohm are connected with the cell of how much? 2 volt having internal resistance 0.5 ohm. So you see here circuit diagram is given. So we need to calculate the resistance of the circuit, that means total resistance of the circuit. We need to calculate the ammeter reading, that is current, and it is said what will be the ammeter reading if an exactly similar cell is connected in series with the given cell. Okay, so first we will calculate the total resistance here, that means 1 ohm and 2 ohm are in series, their answer is in parallel with 3 ohm. So likewise we will calculate the total resistance of the cell. Now once you know the total resistance, we know the voltage also, and here you see 5 ohm, it is the internal resistance here, or that is 0.5 ohm. Okay, so internal resistance here, it is misprint here, so in the question it is mentioned here 0.5 ohm. So likewise we will calculate the total current flowing through the circuit, that means total EMF by total resistance, capital R plus small r. So after calculating the total current here, so this was the question. Calculate the total resistance of the circuit. What is the reading of the ammeter? And what will be the ammeter reading if exactly the similar cell is connected in series with the given cell? So one by one first we will solve. So we will see that 1 ohm and 2 ohm are in series. So first we will write here 1 ohm and 2 ohm are in series. Therefore R1 will be 1 plus 2, that is 3 ohm. Now this 3 ohm is in parallel with 3 ohm. So R1 and 3 ohm are in parallel. So R2 we can get here 1 by 3 plus 1 by 3, that is 2 by 3. Okay, or R2 we will get here 3 by 2 ohm. Right, so this is the resistance of this network. Now when I calculate the total resistance, that means R equivalent, that is total R plus small r. Now total R, when I say this is the total R now, 3 by 2 plus small r we have 0.5, that is 5 by 10. Or if we calculate here, LCM is 10, 2 5s are 10, that is 15 plus 5, that is 20 by 10 or 2 ohm. That means total resistance we got from here, that is 2 ohm. Okay, so calculate the total resistance of the circuit, that is 2 ohm. Next, what is the reading of the ammeter? So reading of the ammeter, next part, question number B, that is I we need to calculate here. I equals to total EMF by total resistance. Okay, total EMF we have here 2 volt and total resistance we have 2, that is 1 ampere. So this much current is passing through the circuit. Now the question gets changed. The question is saying that what will be the ammeter reading if exactly the similar cell is connected in series with the given cell. Now if this circuit is getting changed here, now if we change this circuit, and so in the next part just I am wiping this out. Now I am just changing the circuit now. Now similar one more circuit, according to third question, similar one more cell is connected in series with this. Then what will be the ammeter reading? Okay, so what will be the ammeter reading if one more EMF is connected in series? That means we will have 0.5 ohm and 0.5 ohm internal resistance. That means internal resistance will also get changed. So when internal resistance will get changed, that means the total current, that is I equals to total EMF R plus R. That means there will be two resistance, right? So EMF will be 2 plus 2, that is 4, and R we got here 2 plus 0.5. So now this will also get changed. So first we will calculate the total resistance here now, because resistance will also change. Resistance was, you see, for this network we had 3 by 2 plus, now we will have 0.5, that is 5 by 10 plus 5 by 10, right? So total resistance will be 2 5 is 10, 15 plus 5 plus 5. Okay, so that is 25 by 10, or that is 2.5. Now resistance we got 2.5 here. Now after getting resistance 2.5 ohm, what will be the current then? Current is 4 by 2.5, or 40 by 25. Or we will calculate this one. So total current equals to total EMF by total resistance. So total resistance is got 25. Point will remove here, that is 5 8 is 40, 5 5 is 25. Now when you calculate this one, we will get 1.6 ampere. Okay. So if we put two EMF in series, then internal resistance will also get add up, and the total current will be 1.6. Otherwise it was 1 ampere, sorry, right? So total current 1 ampere was flowing when only one cell was connected. Now 1.6 ampere will flow when two EMFs are connected in series. So similarly you will be solving for this type of questions also, right? So we need to calculate here resistance R. So first we will calculate the total resistance keeping it R only, that means as 2 ohm and 3 ohm are there in parallel, so we will get here 1 by R plus 1 by 2, and their answer is in series with 4 ohm. Okay, so we will calculate first total EMF by current equals to total EMF by total resistance. So from there we can get the value of R. Okay, so we will try to solve these questions. So if you have any problem, you let me know so that I can solve these questions in my next video. Lots of questions are there in this exercise, so I have not started a new exercise today. Okay, so you will try to complete these questions. So you see, this type of questions are easy. First we will calculate they are in parallel. So 1 by 4 plus 1 by 6 plus 1 by 12. Now whatever answer we will get, they are in series with 2 ohm and 5 ohm. Okay, so equivalent resistance, how to calculate the potential difference, how to calculate the current, potential drop across a particular resistance. Like today we have solved few questions, so similar questions you will be solving. Okay, so these all questions you need to do in your exercise book. Okay, so these questions are very important. We will start a new chapter, that is household circuit, electrical energy and power in household circuits. So by then you have to complete these exercise questions in your exercise book. Okay, till then, thank you.